Hey everybody, it's Mr. Call. This is your video review for the force and momentum test. If you're looking to do a test retake, we're going to blow through this pretty quick. This video will just be the first half of the test, the first 19 questions. If you're scrolling along, we're going to be looking at question number 1. Are those numbers backwards? My plan has been foiled. Anyway, that stinks. Question number 1. Take a look at this. We have a free body diagram here, and forces are acting to the right, and one force is acting to the left. The first question is, what's the net force? Add up the forces to the right. So the 15 newtons plus the 25 newtons gives us 40 newtons to the right, and subtract the 10 that's going the opposite direction. So that will be an answer of 30 newtons. Number 1 is C. Question number 2. Yes. Question number 2, which direction is the net force acting on the box? Well, since 40 was to the right and only 10 to the left, that net force of 30 that's left over is to the right. And the answer to that one is C as well. I look weird. 3, what's the acceleration of the box in the figure above? Well, we know that this is a 10 kilogram box, and we know that that force, the net force on it, is 30 newtons to the right. So if you take a look at the top of the test to figure out acceleration, take the force of 30 newtons and divide it by a mass. Hey, what's going on? Mr. Taylor, you're interrupting my video.
Sorry about that.
No worries. The mass is 10 kilograms, so 30 divided by the 10. If you come down here, that's going to give you two options that have 3. So which one has the correct units for acceleration? This one does, meters per second squared. That's 3b. Question number 4. Ball A right here is moving, ball B is not. They both have the same mass. If the first ball is moving to the right with a velocity of 15 meters per second, and B is not moving, what is the momentum of ball A before the collision? Well, momentum, back up here, is this equation right here. To figure out momentum, we do mass multiplied by velocity. So if we take the mass of the ball, that's 10, and the velocity of the ball, which is 15, and multiply those two together, we get 150 kilograms times meters per second. Your answer is B. Ooh, I'm so sorry. Wait a minute. That was question number 4. My backwards letters, I'm off on that. So sorry. My bad. We're now going to take a look at question number 5. Question number 5. If ball A collides with ball B, after the collision, ball A is at rest. Remember, at rest means it has no momentum. The velocity is 0. What is the momentum of ball B? All of the momentum from ball A transfers into ball B. And so whatever your answer was for 4, which was 150 kilograms times meters per second, is your answer for number 5. It's also 150 kilograms times meters per second. That is a conservation of momentum question. Question number 6. If there's no friction acting on either ball A or ball B, how far is B going to travel after the collision? Well, if there's no friction, that ball will roll forever until some outside force acts on it. So your answer for 6 is B. 7. Question number 7. A car is traveling east on a highway. A deer jumps out from behind a bush and into the road. So the driver is going to slam on the brakes. When they slam on the brakes, the car starts to slide. Now, which direction is the force of friction? Remember, if motion is this way, friction always works against the force of, or against motion, right? So if the car is traveling to the east and sliding to the east, then friction has to be to the west, the opposite direction. Question number 8. Hey, is this one backwards? Can't tell because it's so symmetrical. I really like number 8 now. A girl is testing her new car in the Bonneville Salt Flats in Utah because the Salt Flats blah, 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 right? You have to read it, but the only useful information is that the car, after going 175 miles an hour, starts to slow down when she takes her foot off the gas pedal. It goes slower and slower, and she's not touching the brakes. Why would it slow down? There's got to be something making the car stop, and in this case, it's friction. It's not sliding, so it has to be rolling friction. Your answer is A. Number 9. When the net force acting on an object is 0, so when the net force is 0, which of these is true? The object's motion does not change. the object accelerates, the weight of the object decreases, or the inertia of the object increases? It's A. The object cannot accelerate, can't speed up or slow down if the net force is 0. Question 10. An object with a lot of mass also has a lot of inertia. This is Newton's first law when he's talking about the law of inertia. An object at rest is going to stay at rest. If it has a ton of mass, it's going to really stay at rest, and it's difficult to get it moving. Question 11. This one's fairly symmetrical as well. If you're traveling in a car quickly and you slam on the brakes, we've all done this before, right? Which of the following explains why you keep traveling forward? Oh man, look at that. Whoa. You keep traveling forward. Why? Well, the net force acting on you is 0. Nope. That's a typo right there. Centripetal force, there is no centripetal force in this case. The friction forces acting on you throw you forward? No, that doesn't even make sense. Your inertia keeps you moving when the car stops. There it is. Your answer is D. It's Newton's first law. Question 2. Weight is equal to mass multiplied by the acceleration due to gravity. Okay, weight is equal to the mass multiplied by gravity. Oh, darn it, that was 12, in case you just tuned in. Weight is equal to the mass multiplied by the acceleration due to gravity. That acceleration due to gravity for us is always going to be 9.8 meters per second squared. Okay? 13. Acceleration due to gravity on the surface of the moon is about 1/6 the acceleration due to gravity on Earth's surface. That's because the moon is about 1/6 of the mass. So what will the weight of a space probe be on the moon? Well, it's going to be 1/6 what it is on Earth's surface. Weight, remember, is how hard gravity pulls on an object. If the moon has less mass, it can't pull as hard on the object. So the answer is C for 13. Question 14. An object that has a net force of 0 cannot be moving. We did this one in the lab. The answer is false. What it cannot be doing is accelerating. 15. Right here. Which two forces act on an object in free fall? Well, if it's in free fall, gravity's pulling on it, and it's running into air molecules, so there will be air resistance. We sometimes refer to that as fluid friction or drag. Your answer is B. Number 16. Which of the following statements is false? When you see that, you got to read them all. Okay? The object is moving, for an object that has reached terminal velocity. Terminal velocity, remember, means that the object is not accelerating anymore. It's falling at a constant rate because gravity down is equal to that air resistance going up. So, which of the following is false? The object is moving at a constant velocity. No, that's true, so it can't be that one. The net force on the object is 0. That's true. That's why the object isn't accelerating anymore. The object is accelerating downward. There we go. That's our false one. Just to be sure, let's read the last one. Air resistance is in an upward direction. That is a true statement as well. So the only lie here, the only false statement is C. Number 17, coming at you. If a tennis ball and a bowling ball have the same momentum, which statement must be true? The tennis ball has a greater velocity than the bowling ball. That sounds like the right answer. Why? If they have the same momentum, remember up here that momentum is calculated by the mass of an object and the velocity of an object. A bowling ball clearly has the bigger mass, so the tennis ball has to have the greater velocity if they're both going to have the same amount of momentum. So let's check the others just to be sure. The bowling ball has a greater velocity. Nope, that would make it impossible for the tennis ball to have the same momentum. Both the bowling ball and the tennis ball have no inertia. That's just ridiculousness, okay? And both the bowling ball and the tennis ball, wow, why do I look? I look normal there for a second. Ooh, have the same or equal velocities. Nope. So our answer is A for 17. This switching back and forth is weird. Kind of makes me wish my head were that big. No, I'm normal. Question 18. A football player really wants to increase the amount of momentum he has. So what do you do? In order to increase your momentum, you have to increase your mass and your velocity. So put on a good amount of muscle mass, that works, and increase your speed. 18, the best answer there is D. Last one, question 19. Two objects of the same size but different masses are falling towards the surface of the Earth. Which object is going to feel the greatest force due to gravity? Well, let me scroll back up here to the top. Both of those objects are going to have the same acceleration. The only way for a very massive object to have the same acceleration as a very small object is if this force is different. If you have a large mass, you have to have a large force. If you have a small mass, then gravity pulls with a small force. So, which one feels the greatest force due to gravity? It would have to be the object with more mass in order to get them both to fall at the same rate. 19 is A. This concludes the first half of the test. I will do the second half in another file. Hope you enjoyed it.